Hello everyone, welcome to our senior design presentation of our subdivision site design at the Antwerp Township, Michigan. My name is Caitlin Rogash. I'm Kate Smith.
Was that Turner? About covered.
To begin with a quick agenda of what we will be discussing in this presentation, a few points to look at are the utility layout, homeowner design, cost estimate, and transportation design. We will be ending our presentation with an analysis of our alternatives and our final design recommendation. Our scope of work is different areas. A parcel layout, which involves multiple AutoCAD drawings, our transportation design, which involves a pavement design and roadway design, our water resources, which include the retention pond design and pipe sizing, and lastly, our construction cost estimate. So for a brief project introduction, our site is located in Antwerp Township, Michigan. This layout highlighted in purple is where we have designed our neighborhood. It is a 40-acre parcel of land, of undeveloped agricultural land. And our developer has recommended that we design our parcel for future expansion to this parcel highlighted in blue to the east. And to point out also, Paw Paw High School is located just south of our neighborhood, so we can close walking distance. So for our first layout is our public utilities layout. As you can see, there are 116 parcels. According to the Antwerp Township zoning ordinance, it states that the minimum lot area has to be 8,750 square feet with the minimum lot width of 75 feet. So up and up to the right-hand corner is just a quick guide of what we use as our base dimensions when designing this parcel or this layout on the bottom. You can see there are 2 cul-de-sacs and 1 retention pond down here in the northwest. So now highlighted in yellow is our maximum and minimum size parcel. The maximum being just over 18,000 square feet and the minimum just over 8,000. This is just a better visual of our public utilities layout located on top of Google image. You can also see Paw Paw High School is super close to the top. So our second site layout is our private utilities layout. You can see that the parcels are much bigger as we needed space for septic tanks as well. There are only 43 parcels laid out, which is about a third of what is in the public utilities layout. And according to the Antwerp Township zoning ordinance, again, the minimum lot area is 30,000 square feet, and the minimum lot width is 100 feet. And again, in the upper right-hand corner, we have the base dimensions that we used in designing our layout. We have 2 cul-de-sacs and retention ponds. And again, highlighted in yellow is our maximum and minimum parcel sizes, maximum being just over 38,000 square feet, and minimum just over 30,000 square feet. So still within the requirements of the Antwerp Township zoning ordinance. And again, I got a visual of our private utilities layout on top of what we look at.
The design chose this configuration in order to limit the traffic from the south by requiring at least 2 turns to go north to north. And we chose this layout also is from there in the township block length requirements and some street requirements. And highlighted in red, you can see these easements left the eastern expansion of the roadway. And you can see in the public utilities lot, there were 2 easements left open, but even the private utilities, you will have been able to leave 1 or you have to we chose to prioritize the number of plots. Here's some detail. We used a 50-foot cul-de-sac radius as required by the township, as well as sidewalks and crosswalks and a 25-foot turn radius. And we chose to do 2 stop intersections for, again, level speed and safety. For our payment design, we gathered 18 equivalent as load by assuming a 1-car household peak hour traffic, which is 50% of our average daily traffic, and little to no trucks. And we got our certification values based on the 80% reliability for the line serviceability loss index of 1.7, and our measurement of the resiliency of 7,760 based on the Great B soils found on nearby gravel. So we got we did actual pavement design equation to get our required stuff. And then we designed our pavement with 4.5 inches of asphalt as required by the. And so with the structural layer is shown in the lower right-hand corner, you can see that the design structure number 4.2, which is greater than our required structural number, so 4.5 inches of pavement is adequate. Here is some further detail in that document design, you can look at the right-hand corner. Our teams, the top course HMA and the same package for the base course HMA, make up our 4.5 inches total, as well as 6.6 inches aggregate base and 12 inches with the same stud base. And you can also see a cross section of our lending design with 2 12-foot lanes, one each direction with a 2% crossing and 5-foot wide 4-inch traffic. As well as we chose to do a roll curve, and so we minimize destruction when building driveway. Here's a quick look at the topography on our site currently. So as you can see in the southeast, which is 787, the highest 4,000 sites, whereas in the northwest is the local and the 174 feet of elevation. So it gives us about 50 feet of fall on top of that, 2,500 feet of height. It's about 1% gradient, which we will be following in our site design development. So for our utility layout, here is our storm design for the utility layout. The water and will be 5 septic tank. And you can see that our storm lines are based under the curve on what as well as you can see the structure and the retention pond in the northwest. For our public utility layout, we started with the storm layout, which is very similar to the fire. And then the water, we created the loop in order to have connections with the tanks to the left. And the sanitary we placed on the east side of the road to create distance for the water. And the connections to the utilities will be made in the southwest corner. And currently, the utilities are stopped in the city limits, which are approximately 1 mile away from the site. So that would be factored into our cost estimates. We actually buy utilities. And as you can see there, we designed these utilities so that they will be able to be contributed to the proposed expansion. We've studied the water, the street, and that sanitary manhole top right can be tapped into future use, but the storm will not be further expanded and to not overfill retention.
So looking into our retention pond design, we use the Van Buren County Drain Commission standard. They have 3 options for stormwater control. We decided to use the SES curve number method, and we looked at a 24-hour 100-year rainfall event. Some general site information that I mentioned, it is 40-acre parcel. The 24-hour 100-year rain event is at 6 1/4 inches. And from soil borings around the site, past soil borings, we have a soil grade. So moving into our calculations, on the left we have our private layout, and on the right we have our public. So these are 4 little equations that we had to look at in sizing our retention pond. So the first we have our surface runoff. For our private we have 3.12 inches, and for our public we have 3.68 inches. This is due to the impervious area. So on the public we have more parcels, more houses, more impervious area. So we're going to have a higher surface runoff rate. Going from our runoff rate to our curve number, we took an average of the impervious to non-impervious area, took the average for those for both sites. From here, to get our volume for our retention pond, we need to know our peak runoff rate and our time to peak. So if you notice, on our private, we're at 27.82 cubic feet per second, and on our public, we're at 36.16 cubic feet per second. Again, this is due to the impervious area. We're going to have higher flow rates because there's more roadway surface and surface on the lot. We need our time to peak for our storm hydrograph to be in the next slide. And we notice again that we have 1.87 hours and 1.66 hours times feet of these small. So getting into the storm hydrographs on the left, again, we have private, right, is public. You see that the private is just over 25, and our public is just over 35. The area highlighted in red is the volume needed for our retention pond. So we take the area of the area highlighted in red, and then we times that by 3,600 seconds to get our volume. From here, we go on our retention pond design. So we use the general truncated square pyramid for our design for each calculation. So for our private layout, we have a volume of just under 70,000 cubic feet. Due to the standards of the Van Buren County Drainage Commission, we have a max depth of 6 feet, and these ponds have a 4-to-1 height, 4-to-1 ratio for slope for ease of maintenance around the pond. And then our area at 17,000 feet. Moving into the retention pond public, slightly different shape. We had to do this to save parcels within a lot on the public and keep our 50-foot radius for our cul-de-sac. So again, we had to keep a max depth of 6 feet, and our volume is just over 80,000 cubic feet. So using our runoff rates, fiber inlet pipe, again, we have 27.97 cubic feet per second for the private, and then for the public, we have 36.02 cubic feet per second. Due to availability in market right now, we decided to use the rubber joint concrete pipe. And then we went with Manning's equation here. And for the private, we got 29.68 cubic feet per second. And in the public, we get 40.49 cubic feet per second. As you see below, the required was the 27.97, and our calculated was above that. So we were able to use a 21-inch diameter concrete pipe for the private, and then for the public, we were able to use a 24-inch in diameter inlet pipe into our. And moving on to the estimation portion of our project, beginning with the transportation costs. The transportation estimate covers the cost to construct both the roadway and the sidewalks for both sides. So see the column all the way on your left. Both the public and private layout use the same cost codes to determine their estimate. Slightly different quantities, and both estimations come out to a total of about $840,000. These next couple slides highlight the largest difference in cost between the two layouts. Looking at the table on your left, the public stormwater and utility costs is broken down into 4 different sections, being the public water, sanitary, storm system, and the connection to Paw Paw. As previously stated, water and sanitary lines do not currently come to the site. Those both end around the eastern village limit of Paw Paw. So that is one major cost to consider for this layout that obviously doesn't have to be considered for the private layout. And the total cost for everything comes out to an estimation of just under $4 million. Looking at the table on the right, those first 3 sections I highlighted just a couple of those major line items that are driving those costs. The bottom portion of the table, we have the full breakdown of the estimation of that connection to Paw Paw. As you see from those bottom 2 line items, it's going to take about a little under a mile of pipe each for both water and sanitary to get to our site. And adding that into the necessary installations along the way, being the fire hydrants, sanitary sewer manholes, gate valves on top of the excavation of backfill. Total estimation for the connection of Paw Paw is about $1.14 million. In comparison, the total estimation for the private stormwater utilities is about $1.4 million. The private storm system estimation does not differ that much from the public's, other than, as Zach said, the use of 21-inch diameter pipe versus the 24-inch use in the public layout. And the bottom of the table, the private utilities is the largest difference between the 2 layouts. Once again, water and sanitary lines do not come to our site. So we had to factor in a cost for an individual well sanitary system for each lot. The estimate for the installation of an 80-foot well was taken from a
local company in the area, and the private sanitary system factors in everything needed from the septic tank, the distribution box, and everything required for the drainage field. And that was designed to hold up to a 5-bedroom house. My two cost groups to discuss are the earthwork and miscellaneous cost estimations. The earthwork estimation came through the initial cost to stake and clear brush off the site, as well as the cost to excavate those ponds. The miscellaneous cost estimate covers all of our costs for the road signs on site, the fence around our retention pond, as well as 4 different types of trees following the local ordinance. You'll see the public cost comes out a little higher than the private cost, and that was due to the more trees being required on that layout with different parcels there. Looking at our alternatives, all the costs are put together in the table above, and total on the column to your far right. The total estimate for the public layout comes out to just under $5 million, much higher than the estimation for the private layout being about $2.33 million. But when you factor in how many parcels we're able to put on each layout, the cost per parcel for the public layout ends up being about $12,000 lower per parcel on which brings us to our final decision matrix. Each item was scored on a scale from 1 to 5, weighted based off the needs of our developer. The cost per parcel was given a weight of 50%. This was the main reason for our analysis. The constructability and potential for expansion were both given a weight of 20%, as these both pertain to the future needs of our developer. And sustainability was given a weight of 10%, as with any good design, this is an important thing to factor in. The scores for the cost per parcel were based off those numbers you saw in the last slide. Constructability was based off the theoretical ease of construction for both layouts, with the major factor being the mile-long construction required for the public layout on the right highway. For potential for expansion, that was based on 2 different factors. One previously discussed, for the public layout, it allows for 2 access points to the 100-acre lot, where the land will make a lot 1. And also, in the future, if the developer decides to put public utilities on that 100-acre lot, the utilities would already be brought to the neighboring lot, so the cost would be minimal in comparison to our public layout, our design per parcel. And lastly, sustainability was given equal support for both layouts. Both designers did a good job at meeting the current needs of the area, while in their own unique ways, allowing or not preventing the needs of future generations. So, in total, adding all those scores together, factoring in our weights, the public layout received a score of 3.7, higher than the private layout score of 3.2, giving us our final design recommendation being the public layout. At this time, we'd like to thank everyone for coming. I'd like to give special thanks to our sponsor at Whiteman, Mr. Paul Harvey, Mr. Paul Schramm, for giving us the project and guiding us along the way. I'd also like to thank our WME faculty advisor, Dr. Haynes, as well as Dr. Larry and Zealy, for providing us with the support we needed as well.
Paul Schramm, our WME grads, our program, giving back and sponsoring project. Always great to see graduates going out there and giving back by sponsoring projects. Getting a pretty good rhythm right now that happening. So kudos, and hopefully we can have to that with this core of students that are graduating and go out there. So questions for Team 2? Not to the audience. Nice try though. If the jury doesn't have anything, I might have to go to the audience. Yes, all right.
So, did your public utility documents factor in the expansion? I think that might not have been part of your project. the sizing and everything like that, but then
Like,
that 100 acres, that would be huge for the developer if your utilities take into account the expansion, right?
Yeah.
right.
So the pipe side of things we went with will handle the future site, the 100 acres to the east. We just put it to the site currently because we don't know what's happening to that site in the future. We stubbed it. It should be an adequate size, and that's what we've left our costs and costs to.
Yeah. Okay. Yeah, because that would, if you had to put in all that piping and then go back,
Yeah.
by being able to expand 100 acres, that huge value to the developer.
Yeah.
I'm curious, it's a good presentation, by the way, but, the increased density, the sanitary sewer with all of these septic systems, when you look at all the capacity of the soil to take care of that and accept that density of septic systems.
So we went with due to the soil borne that we had, we came up with soil grade B. The infiltration rate for that soil is pretty good, so we just kept that as our base.
Yeah, that's all.
Was there thought about, is there the availability there to use the water system, but not the sewage system?
I guess I don't understand.
You get water and sewer from the city of Paw Paw.
Yeah.
You have to get both.
Yes, both have to be run. Yeah. There are no current utilities at the city.
I mean, could you just have brought water out there? You do get well. And then,
We made the decision that it would be best to just go down to alternatives, designing for either just sanitary, just water.
That's
Yeah. So kind of related to Paul's question, did you look at the feasibility of connecting to the existing sanitary sewer? So, specific to bring, the run on gravity or which is a pump station, and then just factor that into your cost?
So for the public layout, a lift station would be required to get water back to the main line. For our storm gravity bed defined, and then the sand is wait for the alternative gravity.
And then in your site layout, the size of each parcel, did you consider for, if you went with private, an additional septic tank when they fail in 20 years? It would be road site and factor that into your sustainability calculation.
We just put all of the specific 30,000 square feet as required by the county. We did not consider it. It was specified for lots.
And then was there any freeboard calculated in the sizing and layout of this? Any freeboard?
So for the time calculations, we didn't factor in our storm graph, we didn't factor in the infiltration rate, and we also, when we did our calculations, we rounded to the next whole number for sizing purposes. So in reality, our retention times don't need to hold that value necessarily. That would be the max. So that was our kind of our safety factor instead of using the infiltration rate, sizing it down, including safety factor. We just eliminated the infiltration rate and then scaled. Wow, we rounded our values up with one. That would be true. Yes.
Which